Hi there everyone. This video and this frame have been a long while in the making, but I am so excited to finally be able to share this with you. This is the AOS UL7. It's a lightweight 7-inch frame designed for maximum flight performance and maximum propulsive efficiency at minimum weight. It's perfect for long-range flying, fast chase work, and even dynamic freestyle. In this video, I'm going to be taking you through every feature of this design on the bench, and we're going to be talking a little bit more about what makes this frame unique and why it looks so different. I'm also going to be showing you a black box log analysis of the frame so you can see the real world flight performance of the design. And if the AOS UL7 is the right frame for you, I'm also going to be telling you where you can order yours today. If you're thinking of using the AOS UL7 with the DJI O3 Air unit, I'm going to be talking a little bit later on about how AOS frames are going to support the O3 system moving forward, so make sure you watch that so you get the right frame for you. It's a lot to cover in one video, so let's not waste any more time. Let's dive right into it. As always, if you have any questions or comments, please leave them down below and I'll do my best to answer as many as I can. Okay, let's take a look at the UL7 on the bench. And we'll start with the arm structure because this is critical to the performance of the frame and it drives the rest of the design. The AOS UL7 uses a vertical truss arm structure, which means that rather than having a single arm with the carbon fiber plate orientated horizontally, we have two struts with the carbon fiber plate orientated vertically. And this provides some really neat benefits. The first is we can have a tapering effective thickness of the arm from 25 millimeters at the root down to 10 millimeters at the tip. That huge depth to the arm provides enormous vertical stiffness, so much so that we can get away with using just a 2.5 millimeter thick plate for each arm strut. And more than that, we can then cut that plate out to save even more weight. So that gives us our vertical stiffness. The horizontal and torsional stiffness is provided by the truss structure. We have this second strut here separated from the first by an angle, and that just provides incredible horizontal and torsional stiffness for its weight. A second benefit is a thin arm strut like this doesn't obstruct the thrust column from the prop. You can see that the air from the prop can just pass down through this arm very, very easily, and that improves propulsive efficiency, which means that the UL7 can fly faster and further for longer. If we come out to the motor mounting, we can see here that we've had to completely redesign the motor mount to support this new vertical truss arm. Here we have two thin plates, a top and a bottom plate, separated by these short standoffs, and the vertical arm locks into those plates with these tabs and slots here. If I turn the frame over, you can see that the bottom motor mount has a cutout, which means that you can still access the motor screws to replace a motor without having to disassemble this whole motor mount here. If we look now at the top plate, you can see that the UL7 has the 32 by 32 millimeter M3 GoPro mounting pattern that's standard on most AOS frames. And we have press nuts in the top plate so you can screw the GoPro mount straight down, no problem. The GoPro mounting and the FPV camera are forward of the front motors, and that helps keep props out of view of both the FPV camera and the GoPro mount as well. As we move backwards, you can see we have captive battery strap slots, 3 sets front, middle and rear, which is perfect for mounting larger batteries or multiple lithium-ion packs if you're flying really long range. In the middle of the frame, you can see the UL7 has hard mounting points for SMA video antennas. And this is important because if you're flying long range, you'll want to use long antennas for the best reception, and those create a lot of vibration. By having a hard mounting point, we increase the stiffness of the antenna mounting as far as possible, which minimizes the vibration. And by having the mounting points in the middle of the frame, we minimize the length of the moment arm that vibration has to act on. And that means that any vibration will not perturb the quad as much, particularly on the pitch axis. And that's going to lead to overall better flight performance if you're running those longer antennas. If we flip the frame over, you can see the electronics mounting patterns. We have front, middle and rear stack mounting. And the stack mounts are 30 by 30, 25 by 25 and 20 by 20 for all 3 stacks. The camera plates on the UL7 use this AOS Infinity cutout, which supports the original DJI camera, all standard 19 or 20mm cameras and the DJI O3 camera as well. The rear standoffs on the UL7 are spaced 32mm apart, and that's the same spacing as on the AOS 5, AOS 5.5 and the AOS 7. So any 3D printed mounts for those frames for things like GPS are also going to be compatible with the UL7. Let's take a look at the weight of a typical UL7 build now. So here's my build with 28 06.5 motors. It's got the original DJI Air unit in it, and it comes in at 515 grams. If we add props, and that's going to bring it up to about 552 grams, and with a GoPro, 736. Now the battery that I've been flying for longer flights is this 5200 milliamp hour 6S. And with that on, you can see the whole frame comes in at about 1500 grams, just under. Because this frame is such a unique design, I want to take a moment to give you some assembly tips now. Let me take you through how I assemble the UL7. I start by attaching all the long standoffs to the bottom plate and all the short standoffs to the bottom motor plates. Then I assemble the motors onto the top motor plates before building each arm individually. Once all 4 arms are assembled, I build the electronics in the main body of the quad, and I measure and cut the motor wires and then solder them down to the ESCs. Once everything is assembled in the body of the quad, I bring it all together and close it up like a clamshell. I found that it can be a little tricky building one of these the first time, so don't rush, take your time. It will all go together perfectly, and the flight performance is more than worth it. Now that we've gone through the design of this quad on the bench, let me take you through a black box log analysis so we can see the real world flight performance of the frame in action. Alright, so let's take a look at the frequency versus throttle plot for the UL7 on the roll axis. And this is the gyro scale data, which means that no filtering has been applied to the gyro as yet. And I want to call your attention to the low frequency performance of the frame. The first resonance of the frame is up at 190 Hertz. That's a really high frequency. But below that, we have almost no vibrational noise at all. And that's fantastic for flight performance, because that means we don't need lots of low pass filters or notch filters at low frequencies, which add a lot of delay. And it also means that we don't have any low frequency vibrations which should come through in our GoPro footage as blur or jello. Nothing like that. We just have this first resonance at a higher frequency. Now, you can see what filtering I have applied here. I just have a single D-term low pass filter at biquad type from 75 to 100 Hertz, and no other gyro filtering applied whatsoever. Well, I should say no low pass filtering applied, because I do have RPM filtering and a single dynamic notch enabled. So let's switch to the filter trace and see what happens there. You can see that the RPM filter and the single dynamic notch just crush all that high frequency noise and eliminate it completely, and leave us with a beautifully clean gyro trace, which is just perfect for putting into our PID loop. We couldn't really ask for more than this. If I now switch to the pitch axis, again, we're looking at gyro scaled, so no filtering has been applied, and it's the same story as what we saw on roll. We have a visible resonance at a higher frequency this time, 220 Hertz, and below that, really very little resonance noise. And that's fantastic. It means we don't need any low pass filters or notch filters down low, no delay, and no blur or jello in the HD footage. If I now switch to the filtered gyro trace, again, we see that the RPM filters and the dynamic notch just crush all that noise, eliminate it completely, and leave us with this beautifully clean trace, which is exactly what we want to see. Just for completeness, I'm going to show you the yaw axis now. All frames that have this kind of truss structure for the arms perform typically very well on yaw, and we can see that that's true here. We don't really have any visible resonances, very little noise, and that's what we want to see. Obviously, when we switch to the filtered gyro trace, the RPM filters wipe out the rest of that noise and leave us with a completely dark plot, which is just exactly what we want to see. I can't tell you all how proud I am of the performance of this design. I really think the UL7 is setting a new benchmark for 7-inch frames in terms of flight performance. And if you want to try out a UL7 for your next build, you can order yours today from CNC Drones. There are links down in the video description, and if you follow them, it will take you to this page where you can order your UL7 with a choice of standoff colors for both the main standoffs and the standoffs on the motor mounts as well. I want to let you guys in on a little secret, which is that a colored carbon fiber option for the UL7 is coming very soon. And that actually Nick does have some colored carbon fiber in stock, not much, but some. So if you really want a colored carbon fiber for your UL7, then in the comments at the end of your order, make sure you add a request for a colored carbon fiber. I think there's blue, red, green, gold, and silver options. It will depend on what Nick has in stock, and he is getting a restock of colored carbon fiber next week. But that's a little tip for you if you can't wait for the colored version. I want to take a moment to talk about DJI O3 camera compatibility for AOS frames moving forward. I have started to design a custom soft mount for the DJI O3 camera, and that will be launching in the next few months. There will be an upgrade path for all existing AOS O3 frames to this new camera mount. You will require a new top and bottom plate though, because the camera plate spacing is slightly wider. If ND filters are a critical feature for you on O3, then just wanted to let you know that I am working hard to support this feature, and that will be coming as soon as I can manage it. And that brings us to the end of the video. I hope you enjoyed learning a little bit more about the AOS UL7, and if you do decide to pick one up, I really appreciate your support. That's all I have for today, so until next time, I wish you all very, very happy flying.